Today we'll learn about 3D structures in the VSEPR theory. Now, what is the VSEPR theory? The main idea behind the VSEPR theory is that we can determine the 3D shape of a molecule by minimizing the repulsiveness force between electron pairs around the center atom. Electron pair repulsion is the repulsive force that occurs between electrons, causing them to be positioned as far apart as possible in the molecule. For VSEPR theory, the shape of the molecule depends on the number of electrons around the center atom. It depends on bonding pairs, which are electrons that are shared between atoms, basically single bonds, and then lone pairs are the electrons that are non-bonding but on the center atom. However, lone pairs not on the center atom don't play a role in determining the molecular shape. Now, the first shape is linear. Linear occurs when the center atom is bonded to two elements and has two electron pairs. For example, we have BeCl2. First, we'll draw the Lewis structure, and Lewis structure will look like this. These are your bonding pairs. And then lone pairs, you don't have lone pairs as beryllium only needs two bonds. So linear is basically, so with no lone pairs and there's two bonds to the center atom, it forms a linear. Now, the next one is trigonal planar. Trigonal planar is basically a center atom with three elements bonded to it. This is its shape and it has no lone pairs, so the center atom is bonded to three other elements and has no lone pairs, so only bonding pairs, and each angle is around 120 degrees. Now, an example is BH3, where the Lewis structure, you have your boron in the middle, you can draw your hydrogens, that would be your VSEPR shape, trigonal planar. But you have to draw the angles, so you can't draw it like this. You have to put in the angles. This is how it would look like in 3D. The next one is tetrahedral. Tetrahedral is when a center atom is bonded to four other molecules and has no lone pairs. An example is methane or CH4. So basically, the Lewis structure, your carbon is bonded to four hydrogens. This is your Lewis structure. Alright, to draw the VSEPR of methane, you would draw your central atom, then you would draw hydrogen coming out normally. Then you would draw a small triangle filled in as a bond. This shows that it's coming out of the page. And then you draw a dashed line with another bond. This shows that it's going into the page. And this is your tetrahedral shape. And as you see, there's no lone pairs on the central atom. So when a molecule has four bonds, you would draw a tetrahedral, two normal bonds, one triangle, and one dashed. Now the next one is trigonal bipyramidal. Now trigonal bipyramidal occurs when the central atom is bonded to five elements. An example is PCl5. So you have potassium in the middle and it'll be bonded to five other molecules. Now, potassium would have no lone pairs because the Lewis structure would be like this. The VSEPR structure for trigonal bipyramidal, you would draw three normal bonds. Your last two, you'd have one coming out of the page, so it'd be like towards you from the screen. And then you would have one coming into the page with dashed. So basically trigonal bipyramidal. You have five bonds and three of them are normal. And then one is again triangle, which is showing it's coming out of the page, and one is dashed, which is showing it's going into the page. Now, another shape is octahedral. Octahedral is when the central atom is bonded to six different elements and has six electron pairs or six bonds. Example can be SF6. The Lewis structure of this would just be 6 fluorines bonded to the sulfur. VSEPR theory shape for octahedral, you would have fluorine going up, fluorine going down, and then you would draw dashed lines going into the page, a bond going out of the page. Then you draw again another bond going into the page, and then another bond going out of the page. So you have 2 dashed lines now, 2 triangle bonds, and then 2 normal single bonds. This is octahedral. Angle is 90 degrees for each of your bonds. Now, for octahedral, it does matter that you have the top and bottom as single and the sides as dashed and triangle. And it does matter that one side has one of both. So one side has one dashed and one triangle. So you need one of each on each side. Now also, you can have lone pairs. And lone pairs affect the 3D structure of the molecule. So now, when you have lone pairs, the electrons, they like repel each other, cause your molecule to have a different shape, because like the repulsiveness force pushes your molecule apart. Now you can have a bent shape when you have lone pairs. So bent occurs when one central atom is bonded to 2 elements and has 1 or more lone pairs. So an example is H2O. So you have your oxygen atom, it's bonded to your hydrogen, and it has lone pairs. For the 3D structure of bent, you have your central atom with lone pairs, and then after you draw your bonds on an angle, doesn't really matter how much, usually 120 angle, but it doesn't really matter as long as you roughly draw it. And the bend is caused by these electrons as they push each other away, causing the molecule to bend. So for bent, you have your central atom and the bonds bend over, and then you have your lone pairs. Now the last 3D structure with the lone pair is trigonal pyramidal, and this one occurs when you have a central atom bonded to 3 molecules. So an example is NH3. Basically your Lewis structure would look like this. You have your nitrogen bonded to 3 hydrogen atoms with a lone pair. Now, but because you have your lone pair, the 3D structure or the VSEPR theory structure, the lone pair would cause your bonds to create an angle from each other. So for trigonal pyramidal, you have a normal single bond bending, but then you have triangle bond, and then a dashed one. And these ones, when you draw, you have to draw these ones closer to each other. So this one would be further from this one. So you have to draw this one, the triangle bond, closer to the dashed one. Because your 3D structure, you would have like a bond going down, a bond going down this way, and a bond going this way. So you'd have a bond going into the page, out of the page, but towards sideways a little bit, because it's bent also. It has like the bent structure, but because it has a third bond, you're going out of the page on an angle. So your trigonal pyramidal structure is 3 bonds, one's normal line, pyramid one, and then a dashed one. Okay, now let's have a practice. Let's say we have BF3. We draw the Lewis structure. Lewis structure should be like this, and there's no lone pairs. So then we recall all the structures, and we know that 3 bonds or 3 elements bonded to the central atom has to be trigonoplanar or trigonal pyramidal. Now, however, this one does not have any lone pairs. That means it has to be trigonoplanar, because that one is for molecules with no lone pairs. So then you would draw your structure, all normal lines as bonds, but then you put them on an angle, on around 120 degree angle, and then you can add in your lone pairs for your bonded elements. Now these lone pairs do not affect the shape. Now let's say you have something like a bigger molecule. For molecules with more than one central atom, you kind of take them both individually. So your Lewis structure would be like this. That would be your Lewis structure. Then for your VSEPR theory, you would take each central atom individually. So you look at the carbon and then your nitrogen. So the carbon has no lone pairs and has 4 bonds. That means it has to be tetrahedral. That means its shape will be a tetrahedral. And then this one, it has lone pairs of 3 bonds. That means it has to be trigonal pyramidal. Then you would draw a VSEPR shape combining both of these. So to do that, you would draw your bond, nitrogen, carbon together. Then you would draw a normal bond. Then you would have your, since you have the tetrahedral, you have to draw a triangle bond, and then a dash one for the hydrogens. See, this is now your tetrahedral shape. Now for this one, you have here normal bond, so that means you still have to do your triangle bond and your dash one for the trigonal planar, and this would be your VSEPR theory structure. And then to naming, you would just name both. So you'd say there's a tetrahedral and trigonal pyramidal. Thank you for watching, like and subscribe.